2 years ago, AI could only talk. You typed a question, it typed back, and that was the end of the story. Today, AI can act. It books appointments, writes and runs its own code, searches the web, and finishes multi-step jobs while you go get coffee. That single leap from a chatbot that answers to a system that does has a name, the AI agent. In the next few minutes, I'm going to open the hood and show you exactly how an agent thinks, acts, and sometimes spectacularly fails, so that by the end, you understand the architecture behind every autonomous AI you've heard about. This is the series where we go one layer deeper than the tutorials. Today's layer, agents. Here's our path. What actually separates an agent from a chatbot, the four parts every agent is built from, the loop at its heart, the famous ReAct pattern with a live trace, tools, memory, planning, multi-agent teams, the frameworks you'll hear named, and the part nobody likes to talk about, the four ways agents break in production, plus when you absolutely should not use one, and interview questions at the end. Let's start with the shift, because it's bigger than it sounds. A normal LLM call is one and done. Input goes in, output comes out. The model has no memory of what it just did and can't check whether it was right. An agent flips that. It's given a goal, not just a prompt, and then it runs in a loop, thinking about what to do next, taking an action, looking at the result, and adjusting over and over until the goal is met. Picture the difference between asking someone for directions versus handing them the keys and saying, "Get us there." One responds. The other takes responsibility for the outcome. So here's the definition to hold on to. An AI agent is a language model placed inside a loop, given tools to act in the world and memory to track what's happening, that autonomously decides each next step to accomplish a goal. The LLM is the brain, but a brain alone can only think. What turns thinking into doing is everything we wire around it. Let's look at those parts. Every agent, no matter how fancy the framework, is built from four pieces. The brain, the LLM that reasons and decides. Tools, the functions it can call to actually affect things. Search the web, run code, query a database, send an email. Memory, both short-term, the scratchpad of the current task, and long-term, a store it can look things up in later. And planning, the ability to break a big goal into an ordered sequence of steps. Take any one of these away, and the agent gets dramatically weaker. Together, they're what let a model operate on its own. Now the engine room, the agent loop. It's a cycle. The agent reasons about what to do next. It acts by calling a tool. It observes the result that comes back, and then it reasons again with that new information. Think, act, observe, around and around, until it decides the goal is complete and returns a final answer. This loop is the single most important idea in the whole video. A chatbot does one pass. An agent does this loop 10, 20, 50 times if it has to, and that persistence is exactly where its power and its danger both come from. The most influential way to run that loop has a name, ReAct, short for Reason Plus Act. Before the model takes any action, it writes out its reasoning in plain language, a thought. Then it picks an action. Then it reads the observation. Then it thinks again. By forcing the model to think out loud before every move, ReAct keeps it grounded and far less likely to wander off. It's chain of thought from our last episodes, but now the thinking is interleaved with real actions in the world. That's the leap. Let me make that concrete with a real trace. Suppose the goal is, what's the weather in the capital of France? The agent thinks, I need the capital of France. That's Paris. Now I need its current weather, which I don't know, so I'll use a tool. It acts, calls a weather API for Paris. It observes 18 degrees, light rain. It thinks, I now have everything, and answers. Notice what happened. The model didn't pretend to know the weather. It recognized a gap, reached for a tool, and used the real result. That's an agent earning its keep, which brings us to tools, the agent's hands. Tool use, often called function calling, works like this. You describe the available tools to the model, their names, what they do, and what arguments they take. When the model wants to act, it doesn't run anything itself. It outputs a structured request, call get weather with city equals Paris. Your system executes that real function, gets the result, and feeds it back into the loop. The model decides what to call. Your code does the calling. That clean separation is what makes tool use both powerful and controllable. Next, Memory. Because a goldfish can't finish a long task. Short-term memory is the context window, the running transcript of thoughts, actions, and observations for the current job. But context is finite. So for anything that must persist, past conversations, a knowledge base, user preferences, agents use long-term memory, usually a vector database they can search. And if that rings a bell, it should. That's RAG from last episode. In an agent, retrieval simply becomes one more tool the brain can choose to use. The pieces are starting to connect. Now, how does an agent decide the order of its steps? That's planning, and there are a few flavors. The simplest is decomposition. Break the goal into subtasks and tackle them one by one. ReAct plans implicitly, one step at a time as it goes. Plan and execute does the opposite. It drafts the entire plan upfront, then carries it out, which is more predictable for complex jobs. And the most interesting one, reflection. Reflection means the agent critiques its own work. It produces a result, then steps back and asks, is this actually correct? What did I miss? And uses that self-critique to try again. The reflection research showed this can sharply improve success on hard tasks because the agent catches its own mistakes instead of confidently shipping them. It's the difference between a junior who hands in the first draft and one who proofreads before submitting. Self-correction is a quiet superpower. Sometimes one agent isn't enough, and that's where multi-agent systems come in. Instead of a single generalist, you spin up a team of specialists, a planner that breaks down the work, a researcher that gathers information, a coder that writes the solution, and a critic that reviews it. They pass work between each other, each focused on what it does best, exactly like a real project team. It's more powerful for complex goals, but fair warning, it's also more expensive and harder to keep on the rails. More agents, more ways to go wrong. You don't build all this from scratch. A handful of frameworks handle the loop, the tool wiring, and the orchestration for you. LangGraph, AutoGen, Crew AI, and the OpenAI Agents SDK are the names you'll hear most. They differ in style. Some are graph-based and explicit, some are conversation-based, some are role-based. But under every one of them is the same loop and the same four parts we just covered. Learn the fundamentals, and the framework becomes just syntax. And this isn't theory. Agents are already in your daily tools. Coding agents like Claude Code, Cursor's agent, and Devin read your repo. Write code, run it, see the errors, and fix them in a loop. Support agents resolve tickets end to end. Research agents browse dozens of sources and synthesize a report. Computer use agents literally click around a screen for you. Every one of them is the same think, act, observe cycle you just learned, pointed at a different set of tools. So agents sound unstoppable. They're not. And the next 4 points are what separate people who talk about agents from people who ship them. Failure 1. Error compounding. Because the agent feeds each step's output into the next, a small mistake early doesn't stay small. It cascades. Over a long loop, the agent can quietly drift away from the goal, each step a little more off than the last, until the final result is nonsense built on a confident wrong turn, 10 steps back. Failure 2. Getting stuck. An agent with no guardrails can fall into a loop within the loop, calling the same tool, getting the same unhelpful result, and trying again forever, burning time and money without converging. This is why every serious agent has hard limits, a maximum number of steps, timeouts, and checks that stop it from repeating itself. Autonomy without a leash is just an expensive infinite loop. Failure 3. Cost and latency. Remember, each turn of the loop is at least one full LLM call. So a task that takes 20 steps is 20 plus calls, and a multi-agent team multiplies that again. Agents can be slow and surprisingly expensive compared to a single prompt. In production, you watch this closely. Cap the steps, use a smaller model for the simple turns, and reserve the heavy reasoning for where it matters. Failure 4, and the one that should make you cautious, safety. An agent that can take real actions can also do real damage. Send the wrong email, delete the wrong file, spend real money. Worse, because it reads external content, a malicious web page or document can carry a prompt injection that hijacks the agent and turns its own tools against you. The defenses are non-negotiable. A human in the loop for risky actions, sandboxed execution, and strict permissions on every tool. Treat an autonomous agent with real tools the way you treat a new intern with your company credit card. capable but supervised, which leads to the most important judgment call of all: when not to use an agent. Agents add cost, latency, and unpredictability. If your task is a fixed, known sequence of steps, a plain workflow, a hard-coded pipeline will be cheaper, faster, and far more reliable. Reach for an agent only when the task genuinely needs to make dynamic decisions, use tools, and adapt to what it finds. The mark of a senior engineer isn't using agents everywhere. It's knowing when a simple workflow is the smarter choice. Quick interview round. What is an AI agent? An LLM in a loop with tools and memory, autonomously choosing each step toward a goal. What's the core loop? Reason, act, observe, repeat. What is ReAct? Interleaving reasoning traces with tool actions. How does tool calling work? The model emits a structured call. Your system executes it and returns the result. Biggest production risks? Error compounding, infinite loops, cost, and safety, mitigated with step limits, human in the loop, and sandboxing. And when not to use one? When a deterministic workflow would do the job more reliably. So here's the whole picture. An agent is a brain, plus tools, plus memory, plus planning, running a think, act, observe loop until a goal is done. It's how AI went from answering to doing. And it's the foundation of the autonomous tools reshaping how we work. But it lives or dies on reliability, cost control, and safety. And the wise move is to use it only when the task truly demands it. Master that balance, and you can build things most people only post about. If this helped, subscribe to @Techfluencer Eval, one AI skill every week. I'll see you in the next one.